starting with an overview about machine learning. And I like to take this data science lifecycle that captures pretty well what a data science project usually looks like. So we have the starting point with first usually business understanding to understand the problem that we want to solve. Then we have the data acquisition and understanding phase where we dive into the data and do explorative data analysis and see where we can get there. Then we have the modeling, the actual modeling of the model. And after that, we have the deployment and then monitoring of that and so on. I don't really believe in there's an endpoint in a data science project besides really not using the model at all. Usually we don't have an endpoint. We just switch over to the MLOps lifecycle where we would set up the deployment pipeline and everything, set up retraining of the model after certain time passed or enough new cases come in. And yeah, that's basically the real data science lifecycle. And if that comes to an end, then the project ends. So it's a lot to cover in this data science lifecycle. And that brings me to the Azure Machine Learning platform, what I like to call a machine learning platform as a service, because it basically gives you everything that you need to do anything in this lifecycle. So the training, the data acquisition, the deployment, the monitoring, all of the MLOps stuff you can do in this platform. And it also offers various ways to do all that. So you have no code options, you have low code options and coding options, several coding options actually. You can process data, you can build models, deploy models, manage these models, automate training and deployment. You can either use AutoML if you are really not in data science at all to build a model and then deploy it from there. But you can also automate training like with pipelines, like regular retraining and all that. And Microsoft is also pretty big in responsible AI, so they offer transparency layers for their service that's built into the platform, basically. Speaking of responsibility, an overview about responsible AI. These are also from Microsoft, but they're the pretty usual set of topics that you see around responsible AI. First one is fairness. The AI should treat everyone fairly, regardless of age or ethnicity, if they have the same set of features. Besides that, AI systems should be reliable and safe, which means they should have reproducible results and also resist harmful manipulation, respond safely to input that they didn't really anticipate, and all that. Then there's privacy and security, obviously. Your AI model shouldn't leak data, which was a common problem in the beginning of all these models turning up. And people should also be aware that their data is used in a model, so they know what's happening with their data. It also should be inclusive, which means it should be understandable for everyone and usable by everyone. And to help people understand it, then there's a point of transparency, where the output should be interpretable and understandable, also for non-technical users. It should be understandable. And in the end, accountability. There should always be a model owner or someone who's responsible for the output of the model. That's the only way to really make sure that if something happens, that there's someone who can be responsible for that. Why is all this so important? I wrote down these 7 points, and there are more points, but I think these are the most important ones. First, it enhances the trust stakeholders have in a system, which really helps to adapt these systems and also to build these systems in a better way, because you get more feedback and more knowledge of experts, which is really important for building AI systems. It usually leads to better models, just because of the first point. If you build these models in this way, then you will have a better understanding of the model itself and also the data, which helps in the end to build a better model. It also enables better decision making, because if you get a decision from a model and it's not explained at all, then some people might say, I don't trust this, or why should I trust this? So it helps really to make better decisions in the end. It can protect you of certain legal problems, not every legal problem, obviously, but if you have a system that is secure and has privacy updates and everything, then you are at least to a certain point protected. It also improves possibilities for collaboration, which I think is a great thing, because it's the same as the first point, basically, where you have a system that people understand and that people feel like they are included in. They are much more likely to collaborate on this system and help making the system better. It also reduces the risks of bad press, and I think over the last couple of years, we all heard our fair share of stories where an AI did something incredibly stupid or even incredibly dangerous. I have this one thing in mind where McDonald's tried to introduce an AI that will take your order, and I think it ended up terribly wrong, and people were complaining about the AI not taking the right order, and they had to go back to the usual way of taking in orders. And as far as I know, they're not back yet at using the AI to take orders. It also can prepare you for regulations which are bound to come. In the European Union, there are already some regulations. I think in the US, same, but it's all a little bit slower. But if you use these responsible AI principles, then you are much better prepared to dive into these regulations, basically. So that's for the intro. Gonna jump into the demo. Just have to switch the screen that I'm sharing. Second. Okay, now you should see the Azure Machine Learning Studio. I'm going to go back to the home view. So this is the platform I was talking about. We can already see I'm in a workspace here. I could start projects from here. I see some Gen AI models here, projects that I could start from a template, basically. On the side here, I have a plane where I can go to my notebooks, which we will do, but I also mentioned the AutoML, where you can go to basically build a model without really being into data science. You just have to drop the data in there and say, this is my goal, and then it will do it for you. There's a designer where you have a graphical interface to build a model. With prompt flow, you can build Gen AI applications with the graphical interface, and there are different assets that you can use. Can reuse the data and collaborate with that. You can reuse components if you build something for the data preprocessing. Others can use it too. But the main part we will see today are the notebooks. One of these notebooks here. And I'm just going to start the compute here because we need that later. I'm actually not going to run this because this actually takes the time. But yeah, this is where we start, and I'll provide the notebook later on for everyone to really dive in. Since we have limited time, I will not go into it too deeply. But yeah, I hope I will give a good overview of everything. If you decide to work with the notebook itself, what you will have to adjust if you want to build your own model into here, that you can basically find with searching adjust, and then you find the most important sections. And I also took the time to to put notes on everything to explain what this actually is and why you have to change it or why you have to do it in a certain way, or also things that you can change but don't have to. Okay, so first we have the setup, and well, maybe I preface something. There are different ways to train a model in Azure. I already mentioned the AutoML and the designer, and also these notebooks. And within these notebooks, there are several different ways to do things. We're usually using the Python SDK for the development. You can also combine this with CLI, and this project here is using the components that we also saw here on the side. So we're basically building components that we can then reuse later on. But there are different ways, and I just wanted to preface that. And something else, since we are building a responsible AI dashboard, I'm doing it in a pretty specific way, because this just assures that the dashboard will run in the end, because there are some specifics for the dashboard to actually run in the end. And if you're just adjusting the parts that are marked with adjust here, then you should be able to get the dashboard running without problems. I did it the other way around first, to try to to adjust my model code into the dashboard code, and that was not as smooth as I would have liked it. So yeah, I really would suggest that you follow this this notebook here and this way to make sure that it runs in the end. Okay. So in the beginning, we just have the setup where we give the we define a version, we define a project name, we define a model description that we need later on for the scorecard. We define the target feature here, and then there's a bunch of setup with the where we have the where we will save the rain and test data, because we actually have to save these as a so-called ML table that's then as used as an input in the dashboard later on. So this is the setup basically for this for registering the data assets as machine learning tables. Then we connect to our workspace. That's this cell. And then we connect to another workspace. This is the registry where we later pull the responsible AI dashboard components from, because these are provided by Azure, basically. And then we start with the normal stuff. We load the data out of a config file, or the path out of a config file, load in the data, and this specific project is a churn project for a telecommunication company. And our aim is to prevent churn, or first to detect churn, and then prevent it. We'll look at the data types here. And this is something that I noticed with this data set. The data set is from Kaggle. It's an open data set that is used pretty often for basic machine learning projects. If you want to build this dashboard, then you have to have a few things in mind that you should check with your data board. For one, you should check if your target variable is properly formatted, preferably 1 and 0 for binary, strings for multi-class, and float in for regression problems. Check that the d-types are correct. This specific example, for instance, I have the total charges field here, and you can see it's an object, but total charges should probably be a float. So when I first did this, I actually had an error in the end, that it couldn't find the categorical object total charges. So yeah, bear in mind that these are problems that you should solve before starting the actual model training. So that's what's happening here, basically some data cleanup. Then we split the data and train and test data, save these as Parquet tables, and write these to the location that was in the setup. Another limitation of the dashboard in the end is that the test data set should have less than 5,000 rows. And this test data set is not the test data set that you might use for your model development. It's just the test data set for the dashboard in the end. So you can also just use a shorter version of your test data set if you want to. So we do that. Then we register these data sets that we just divided and register them into the workspace. This will assure that we can later on use these data sets as a input for the model dashboard. Yeah, then we got this out of the way, and we start with the model training basically. And I would assume that EDA and all that is already done. So this is basically just the model development, or it could be like the baseline model, and then you could incorporate the results into the EDA process basically. So first we create some directories, and then with these inline magic here, where we will write an actual file. So everything that's here will be wrote to a Python file. And there is a little bit of boilerplate in here. So I would leave these sections unchanged. The section for the actual machine learning model is in here. And it's also marked by adjust. What happens first is just the arc parser, and then setting up the MLflow experiment here to actually track the experiment and get the model later on. Load the data, and we have some transformations here that we put in a scikit-learn pipeline. Have the classifier over here, and another note here is that the dashboard actually doesn't work with XGBoost, but it does work with LightGBM. So you can use another estimator, obviously, but XGBoost will in the end not work properly. We have some hyperparameters, put the pipeline together, start a random search, train the best model again from the best parameters that we just got, fit the model, and then basically this shouldn't be changed. So this is basically where the model is put into a directory and saved within the component. So yeah, this shouldn't be changed. Otherwise, it might not work again. What I also put in here is a little test line that just tests this script and just locally runs it once. Because what I had happening is that I changed something in the model here, and I just made a little mistake. Then I ran everything again, and it started the pipeline, and the pipeline always takes a couple of minutes. And then it said, oh, I don't know this module because it isn't in the import section, for instance. So I made sure if you run this, then you will see that the Python script actually runs. So that's the training of the model, basically. Then we have another file here for registering the model, and there's not much to it. You don't have to change anything here. It's just another component that will then save the model that we just trained, or is going to be changed in the pipeline that we will define, and saves it so we can later on use this model for the responsible AI dashboard. What we do then is we have the Python scripts now. What we use then is some YAML files to define the components. And this is this section, and there's not much to be changed here. So I will just fly over it. There's one component for the model training, and then there's one component for the registering of the model. Next up, we create an environment that we are going to use within these components here. And it's just a basic Conda environment that we create here. So if you use any more packages than I did for the model training or anything else, you can include those here. And it will create your own environment based on a Docker image that's defined here, and it will just name it project name _ Ray. And if this environment is already in your workspace, then it won't create it again. It will just skip the part. This is basically what's happening here. The next cell is creating a compute. You can use your own compute, and that's in the setup section, where you can just put your compute name in. If you don't put one in and just leave the default, then it will create a small compute cluster, and it's really a small one, just for standard D2 VMs. And it's recommended to use a cluster for the construction of the responsible AI dashboard, because that has several tasks that can run parallel, and that just is helpful to have a cluster then, because it's much faster. This obviously just works if you have the permissions to actually create a compute cluster. If not, then you have to ask your admin to do that for you and put the name of the cluster or compute instance in the setup section. And also to avoid any costs, if you run the whole script here, the whole notebook, then it will delete this compute instance too in the end. Okay, so the compute, now we define the pipeline that is actually gonna do the model training and then the model registering. So we define the inputs for the pipeline. We have the train test set, the train and test sets, open the pipeline and define a little training pipeline that we then put here. This is the a little function that will help you to not only run the pipeline, but also monitor the process, because running this will take some time. It's like between 5 to 10 minutes. It depends on the model and the kind of data you have, obviously. But yeah, it's for me, it took like 5 minutes, and every 30 seconds it will put out the status. And you also see a link here that's provided. If you click this link, then you come to the you get to the job that's actually running the pipeline, and you can monitor it from there too. But yeah, the cell will run for a couple of minutes. And if it's completed, then it means actually that there is a model that's been trained and also registered. So
What usually comes next is to deploy said model, and that's what we do here. I added this to this notebook. Maybe if you don't want to deploy a model, then you can just not run these cells. And for now, there's also a line to delete the endpoint in the end, because the endpoint would also have a cost connected to it. But yeah, we basically define a managed online endpoint here, create this online endpoint. Some of these, I put a notice on here that this runs for about a minute to create the endpoint. Then we get the model that we just trained and create a deployment on the endpoint, basically. So this is the blue deployment. So you can do A and B testing or blue and green testing. This is basically the blue endpoint. And this is where we create this endpoint. That also takes a couple minutes. It can take up to 10 to 15 minutes, but yeah, can in the meantime watch this video about the endpoint. And this is a online endpoint. If you want to build a batch endpoint, I put a link up here to do just that. Then we created the model. We set the traffic for the model. 100% of the traffic should go to the blue deployment. This is basically to have the all the traffic go to the deployment that we just made. And we test the deployment too. And I just use a sample of the test set that we defined earlier, and I get the result of the model. In this case, all of them were not churn, at least predicted by the model. And yeah, this line would delete the endpoint if you don't need it, but you can, don't have to run this cell. Great, we have a model, we deploy the model. The deployment is actually not needed for the responsible AI dashboard. That's why you can delete it if you are just here for the dashboard itself. Now back to the responsible AI dashboard or RAI insights. This is where we define the components of the dashboard. You see that this is here. We just take the latest version of this RAI constructor component, which is basically the core component to construct the RAI dashboard. And we take the version here and then get the components of the same version just to make sure that they are in the correct version, that they are compatible with each other. So what we will have here is a explanation component for model explanations. We have a causal component for causal analysis. We have a counterfactual component to create counterfactual about our cases. I will show all that so you can see what it looks like. But it basically creates a case where you would slightly change some feature in the case, and then that would change the outcome. Then we have an error analysis component, and then basically a gather component that gathers all these components together, and also a scorecard component, which basically puts out a little like a model CV, where you can see the most important stuff about the model that you just built. And that's also what we do here is we define the configuration file of the scorecard. And this is basically a dictionary or a JSON file in the end that's provided. I provided some links to view at what you can actually put in there. What I put in there is are some exploration features here. So features that I want to see on the scorecard and see how these features are distributed and how many of these were, in the end, in the positive class or in the negative class. Then I can also define some sensitive features. If I want to do a fairness assessment, I use the senior citizen and the gender columns here. And then just some setup. It's a classification problem. So if you have a regression problem, then you can change this to regression. That will change the metrics that are used in the card. We use the model description that we defined in the setup section. Then we have some metrics that we want to see on the scorecard, the accuracy score with a threshold over 0.7, a precision score, a recall score, and a F1 score. We want to see feature importance of the top 10 features. We want to add the data explorer for the exploration features, and we want to add the fairness section for the sensitive features. We save this config file automatically to the directory, and this whole long thing here is the dashboard, basically. So what we have here is what we need is the classes in the target. We just have 0 and 1 for our case here. We have a treatment list for the causal analysis. So these are features that we want to treat in the causal analysis, and we will see that later. I think it's easier than to show it and to explain it here. Also for the causal analysis, we have heterogeneity features that basically are a counterpart to the features that we want to treat. So if you have features that you don't want to change or can't change, then you can put them here. For the counterfactuals, we can define features that we want to be able to vary, because we might have features that we can't change in the end, and we don't want to have counterfactuals with features we can't change. For instance, the age of a customer, we can't do much about that to change the outcome of our prediction. So we can put features we actually have power over in here. Dump all these as JSON files, because the dashboard needs JSON files. And then we create another pipeline, basically. We have, again, the constructor component that we loaded earlier. It's still a classification problem, so the task types classification. We given the model info and the input that we defined earlier, the train data set, the test data set, the target column name, and categorical features, and also the classes. And what is kind of important is that we put on this use model dependency. So if you use any special Python package, then you should put this to true, just to make sure that the model actually is loaded into the dashboard in the end. Because the dashboard construction uses its own environment, and you don't have any chance to change the environment that it's used in the construction, which can be a problem if you use too complex or too new packages. But yeah, that's basically the constructor. Then we have the explanation component, just pretty straightforward. We have the causal job, here we have the treatment features and the heterogeneity features. We add the counterfactuals, and the default is actually 10. And I tried to lower this earlier because this job actually takes the longest.
and I try to make it a little faster by changing it to 5. But you should leave this at 10, because otherwise the pipeline just crashes on you, and yeah, you wasted a couple minutes to wait on the pipeline. The desired class for the counterfactuals is for binary problems usually the opposite class, and we have the features that we want to vary here. Then we have the error analysis component, and this is then the gather component that gathers all the 5 components that we just put together. And in the end, we also have the scorecard component. But you don't really have to change much here besides the section in the beginning where you define your own features that you want to see on the dashboard. Okay, so then we define the outputs in the end where everything is stored, and this actually starts the pipeline. And as you can see, every 30 seconds we get a running, and it runs quite a while. So it usually takes between 20 and 40 minutes. So that's also why you don't really want to have any configuration, because sometimes it runs for 30 minutes and then you get an error and have to start from new, which is kind of annoying. So yeah, but this should just run as it is. And yeah, we get also a link here that leads us to the dashboard, which we will see shortly. Just wrapping up this section here. We have the scorecard that I mentioned, and we basically download this here. And in the end, we delete the compute that we created just to avoid any costs. And I also included a troubleshooting section. So if you have trouble running this, yeah, you can check if there any of these points can help you. And I also included an additional materials section if you want to do further reading on all this stuff. Yeah, you can jump into that. Okay, so that's about the model training part. And then we jump into the responsible AI dashboard. I can just open the link, but I can also go through the workspace here under models, open the most recent model, and then go here to responsible AI, and I will have the same, should have the same view. But yeah, this here is then the responsible AI dashboard, and I will start this. And yeah, we can see the dashboard right away. Still up there. This is new. Let's see, reload this. That's the presentation mode. Stack environment. I'll stop this. See if it. I can just restart it, but that might take a couple seconds. But I will go back into the dashboard, because we don't need a compute for the dashboard, but it's recommended to connect a compute, because this provides then all the features that the dashboard yeah, is able to provide. So let's see, the stop succeeded. I'm going to start it again. Just wait for it and jump into the dashboard itself. So yeah, the first thing that we can see is the error analysis. And we see a basically a tree map here of our model, and specifically about the errors that our models did. So I think this is pretty interesting, because many people just look at the accuracy and then they say, okay, the accuracy in this case would be something 81.68%, which might be good enough for them. It's actually not that good, but that's better for me to show you this dashboard.
But what many people don't do is to actually dive into the errors that the model does. And this is basically enabling us to do so. So what we can see here is the tree, and I have this section here, and I see that this section itself has an error rate of 38%. And the error coverage, the part of all the errors is 42.55%. So this already shows me that a huge portion of my errors is just within this section. And we can follow the tree here and see the section is it's all month-to-month contracts. The monthly charges are larger than $40. The total charges are smaller or equal to $1,075, and the monthly charges again are smaller than or equal to $93. And this section then I can dive in deeper, and I'm just waiting for the compute to start again, hopefully correctly this time. And then I will save this as a cohort and dive further in. But yeah, what we can also see, if I have this selected here, I can see this prediction path here, which are basically the filters that this path that I selected has connected. And we can also see how many instances and how many of them are correct and incorrect and all that. So it's just some more information about the errors. And yeah, as I said, I can save these as a cohort, and this is also what I want to do here. I'm just going to call it highest error and save it. And I will actually save another cohort month to month. And one more cohort, not month to month. So now I have a couple cohorts saved that I can use for the further analysis. About this error analysis, if I switch to another cohort now, for instance, the highest error, which I just mentioned, then I'm still waiting on the compute, but usually what you would see is that this error tree changes. It changes to your selection, basically, your cohort that you just saw. But it won't do it now because I don't have the compute connected. So let's see. What we also can see here is the heat map, and we would be able to see it if the compute was working, but it still isn't running. Went totally fine earlier this day. Let me check again if I can see in the compute what's going on. Still starting. Okay, then I'll just skip that part. So the tree map would allow you to, you know what, I actually have that in my presentation because I have a fallback plan. Let's see. Okay. So basically what we can see here is that where we can save the cohort, what we already had. And then this is the heat map view where we can then select features here. For instance, here I selected the contract and the monthly charges, and then I can see a heat map that will basically show the cohorts of data within the selection of features and the error that we can see here. And we can also change the metric that we want to see, which can be helpful if we want to see another metric. So yeah, that's what we can see in there. And yeah, I think that that's already helpful to understand better how our model makes mistakes and where we might be able to improve the model in the end. Because if we can improve the errors here, then we will improve the model overall. So I think the error analysis part of the dashboard is great to have. What we have too is a model overview. And I'm going back into the dashboard because that should work without the compute. And in here, we can see the cohorts that we just created and the comparison to the all data cohort. And in here, we can already see that our model has a significant problem because for the not month-to-month cohort, the false negative rate is 1. And if I connect here the F1 score, the F1 score is 0. So there's a problem here. The false negative rate is 1. The F1 score is 0. In the end, this means that the model, all the cases that are not month to month, it just predicts as they are not churn, because it thinks, because the majority part of these cases are not churn, because if you have a contract of 2 years or 1 year, you're not as easily able to churn. The model kind of learned that, but it learned it the false way and just assumes that every time that the contract is not month to month, that means that the customer is not churning, which is not the case, because in the end of the 2-year period, the customer obviously can churn. So this is a big problem that this model has, even though the accuracy rate in this section is 94%, which sounds great. But yeah, at the end, it's actually pretty bad at predicting churn, because it just assumes for the subset of the data, it just assumes that they will never churn, which is not the case. But it's nice to see this in comparison. You can also see the probability distribution down here. Could also change this to the metrics visualization to see this a little better here. Can choose the cohorts here. Can look at the confusion matrix, but by this point, you should probably have seen a confusion matrix of your model. But yeah, it's just nice to have this in here. And in here, you can also check the confusion matrix for your data cohort. And here we see again the problem. 756 cases of the of this cohort are actually not churn, but 48 cases are churn, and the model just predicts everything it's not churn. So this is something that we could see using this dashboard. Hopefully you would have seen it earlier in the model development, but at least here we can dive into it and see that this is actually a big problem. But we can also use in the dashboard, and it probably won't let me use it now because the computer is not connected. So I'll jump back into the presentation, which I will share later on too, to see the feature cohorts here. So we have the feature cohorts. We select this, and then we select a feature or several features, and we can see again what are the comparison for the feature that we selected. In this case, senior citizen, no, versus senior citizen, yes. And you probably can't see much because it's so small. Let's see. Switch that to presentation mode. Let's see.
obviously presents on my other monitor. Let me change that for now. So at least I can do this to make it a little bigger. So yeah, as I said, we can see the difference here for this feature that we can that we selected, and we can also select more than one feature, and we'll see the subsets then. And we can also see a fairness assessment here. So we have difference and the ratio of the fairness. The difference we want to have as small as possible, and the ratio we want to have as big as possible for the fairness. And we can also see the probability distribution down here and see that there's actually a little change between the senior citizen no and senior citizen yes. So that we should factor that in and maybe take out this feature or do something about it to make sure that it's ethical to use this feature. That's about the model overview. Then we have the data analysis part here. And this is just kind of a nice to have because it's basically just a table view of your data, and it has pre-selected your incorrect predictions here. Can be just useful to check these if you want to just quickly check a specific data point in your dashboard, but it's not very easily usable because you see that the headers here are gone pretty fast, and it's just not that easy to dive into the data here. It's probably something that you can do better in your own notebook. But you also have this chart view where you can see your data here. Let's see, TrueY. I'll put the data set, the contract here. And this way we can already see why our model has such a big problem, because we have more month-to-month customers, and the part of the month-to-month customers that churn in the end is much higher than in the other cases. So that's why it's struggling here, and just kind of also struggling here, but just pretending that everyone in this section will be not churning, which is just not the case. So yeah, we can use this to have a little view into our data, basically. I also mentioned the explainer component, and this is what we can see here. So this is the feature importance of our model, and we can change here the top features that we want to see, but we see pretty quickly that the importance of the features is getting lower and lower. So probably these couple of features here are the most important. And we can already see that the contract is extremely important to the prediction, which makes sense. But that this is important, but maybe we want to do something about it. We could, for instance, build models for each contract type just to make sure, or oversample data, undersample data. There are some options that we have here to mitigate this problem that we already had. So we can see the feature importance. This is the average of the absolute feature importance. We could also look at the directed feature importance. So what is the feature importance when we want to see the negative outcome of the class or the positive outcome of the prediction? And we can also change these to box plots just to have a little more information about everything. And we could change the sort order of the cohorts. And we can also select one of these features.
So Jeremy, there's a question from Sridhar. He's asking why the error rate is higher than all data.
I don't really understand understand what you mean with that. The error rate in this model is total error rate is 18.32%. And yeah, if I switch the cohorts, then it will change, but it's not higher than all data. And yeah.
Okay.
So
okay, thanks. And Sridhar, you can clarify any clarifying questions. Feel free, or at the end in Q&A.
Yep.
Thank you.
Yeah, thank you. So yeah, we can also look at a specific feature here for a specific cohort, and this is something that can be confusing because now I selected the contract feature here, and I just see month to month. And this is because it just pre-selected the highest error cohort. So I have to switch back to the all data cohort to see the feature importance of the different features. And here we can actually see that the contract 2-year is more important for the model. If it sees this, then we already saw the model will just put it to the non-churn cases. And yeah, also if we see month to month, it's also pretty important for the model, and it's much more likely to put it into the will churn cases. So yeah, this is the global feature importance of the complete model. We can also dive into the individual feature importance, which then lets us select 5 feature points here. And let's see, we can select 5 cases that were churn, but the model didn't see them as churn, didn't predict them as churn. We can look into this to see how the feature importance turned out for this specific cases, just to dive in a little deeper here. Yeah, so that's about the feature importance. I think this is helpful. There could be a bigger variety of visualizations, but yeah, I think this is already at least easy to use if we have the dashboard set up. And what I also failed to mention earlier, the dashboard always has these help sections here where we can see what actually is behind this and explanations, how to read this chart and all this, also to explain how to use this model, this dashboard better. Okay. Yeah, next section is the counterfactuals. And I was pretty excited about the counterfactuals because I think in a case where you want to detect churn, your actual aim is to prevent churn, obviously. And the counterfactuals should be an option to do that. And I will dive into this, just putting in true Y here and predicted Y here. And then we get kind of a confusion matrix here. And we can actually could dive into a data point here. So I'm going to select this, and it will show me the most important features again. If I change these features, it's most likely that the prediction will change in the end. We can then also open these counterfactual chart, and it would look slightly different if the compute would connect. I don't know why it doesn't connect. It's just the presentation error that you are bound to have when you're doing a presentation. But the exciting part here is that you can see versions of the row that you just selected, and these all should be ones, and down here you would have a selection bar where you can select the features and set them on your own. And the aim would be to see, okay, how can I have a customer that is churning? What can I change to make this customer not churning?
and this would be based on the prediction. So it's based on statistical values. And if the compute is connected, then there will be a message down here. And I think I have that on the screen again. So let's see, where are the counterfactuals? Here. I don't have the description here, but here you can see that you can select these features here, and you can also see the predicted value of the row that's selected here is 1, and the model created 10 counterfactual cases. So we have something that we can look at to maybe change the outcome of this prediction and maybe have a angle to keep this customer from churning, which is interesting, but it kind of didn't really work that well for me. For instance, I put in the features to vary that we defined earlier, and I put in stuff like gender, senior citizen, partner, dependents. That's not things that we can change as a company for our customer, but still it changes these things in the counterfactuals, which is kind of misleading, and it also would not always compute these counterfactuals. And I think that is within the underlying model that they use, because they basically try to find the closest spot with the opposite prediction, and maybe they just can't find spots that are close enough, or I don't know, but it didn't really work that well for me, and I just want to be open about it. Maybe it doesn't work for you as well. I certainly wouldn't rely too much on it when it comes to decision making, but what we can rely more on is the causal analysis, and that's what we can see here. And this is actually, the counterfactuals are still based on your prediction correlations. So it will also work like your model. And I think an important thing to know is that correlation doesn't cause causality. Probably every data scientist has heard that before. So it's important that these models are sometimes just based on statistical distributions, and sometimes they are not, what they put out doesn't really make sense. It might work, but it doesn't really make sense in a causal way. So the causal analysis works in a different way. And what we can see here is, again, the global analysis for the complete model. And we can see down here the features that we put in as treatment features. And what we can precisely see is when we change this feature from fiber optic to DSL, how would that change the outcome of the case in the end? So how we can read this is basically that a customer that has fiber optic is more likely to churn than a customer that has DSL. And maybe if we change this about the customer, which is also probably not going to be easy. If someone has fiber optic, he probably doesn't want to switch to DSL. But if we change this, then we might be able to keep the customer from churning. And also, we can see there are different other options. For instance, if he has no internet service versus he has the DSL internet service. Because probably in this case, in this scenario, DSL customers are less likely to churn. So this is basically where this comes from. And yeah, this is much more helpful. It also has a bunch of explanations because causality is also not that easy to explain. But yeah, we can dive into the explanations as well. We also can look at the individual causal points, and this is basically the same that we saw for the global model, but this is for an individual case. So we can select the case here out of our view, and then we can see in this case, what can we change about this case to prevent this customer from churning. And I think this is a great tool to actually make decisions based on the model in the end. And what is maybe even better is this treatment policy that is suggested here. This is basically based on the causal analysis, and we can see here a subset of our data that says, for instance, for the phone service, if we have a customer that has no partners and see, it's a double no here. So it is a senior citizen, then it's recommended to not offer the customer a phone service. When the customer has no partner and is a senior citizen, then it's recommended to offer a phone service. And if the partner is, if the customer has a partner, then the treatment is again offering no phone service. And yeah, this is basically much more helpful than the counterfactuals to have a overview of what we can do about our model and how can we maybe prevent customers from churning on a bigger picture. And it also provides us this solution here. Yeah, how it would how the policy, if we change this, how this would change the outcome of the prediction, basically, and at this point prevent more customers from churning, basically. So yeah, that's I think that's it. For the dashboard, the compute still isn't starting for whatever reason. That never happened on me, so sorry about that. Now I'm glad that I actually also put in a click guide into the presentation, because I thought it would be nice if you, because you probably don't recall everything I said. So in the presentation, which I will provide, yeah, you can just go through here and see how you use the board and yeah, just have a view that you can follow, basically. Yeah, so that's it for the presentation. I also in the presentation put in the sources that I used and also some additional resources that are also in the notebook.